All right, welcome to our next video in the series on programming in Java. This is a continuation of object-oriented programming. We're talking about encapsulation today. Encapsulation. So what is encapsulation? It is the idea that we're going to use the private keyword to protect our fields. Why do our fields need protection? Well, if you've been watching this playlist, you know that we've been creating a piece of software to help a dog daycare. We know that the client class is called the kennel. We know that the helper class is being called dog. And we've already identified problems that can come up if we're not careful with our fields. And what I mean by that is, we worked hard in the last video to make constructors. So let's say I make this dog D2, and its name is Boomer, its age is 2, and it has been vaccinated. Well, the way that my code is written, because my variables are not private, I'm allowed to say D2 age equals -17. That line of code compiles, it's a valid piece of Java, but it represents a breakdown in real-world logic. No dog is -17 years old. So how can we make sure that as a programmer, we don't go in and accidentally invalidate a piece of code that we have? Let's say we're providing, some variables for our helper class, whether it's an int or a string or a double or a boolean or a char. There might be something that needs to be true about that field that we want to protect against. And in the case I'm right here, I'm thinking the age of a dog shouldn't be less than 0 and should probably not be greater than 30. I think there are dogs that can live up to 20, so we'll say that 30 is the upper limit. So what I'm going to do right here is I'm going to say, all right, look, name and age and vax, you are all now private. And what does the private keyword mean? Well, it is, as you imagine, it's the opposite of public. Private says that the only thing that can refer to these variables right now must be inside the dog class. If an outsider tries to refer to it, it won't compile. And this is me encapsulating my fields. And you can see right here, it turns off my ability to access my my field right here, age. So it forces me to say, all right, d2.setAge. And now, if I try to do something invalid and I go to run my code, invalid age provided. I guess I should turn off my print statement from before. Invalid age provided. If you recall, if I go down to my helper class and I look at the setter I defined, the setter says, look, you'd better check. This age should be valid. And if it's not, don't update the age to that. Instead, let the user know they've made a mistake. Well, you can further protect your code by saying, all right, well, what if when they try to do the constructor, they try to say like, -29, something like that. I can go up to my constructor and I can say, you know what? When the parameter age comes in, I guess I should do it for age, don't just manually set it. Let's go ahead and use setAge, sending age down. So what that's going to do is it's going to say, all right, -29 is a parameter here. It goes to my constructor. And then I take it and I'm going to pass it down to age. And if that turns out to be invalid, then we're going to get notified. So encapsulation just means add the private keyword to your variables and only allow access to them through public setters and getters. This will make sure that if you've got an int that can't be negative, or a double that must always be less than 100, or a string that should always be shorter than 3 characters, or whatever it is, if there is some truth about your state that if it ever becomes invalid, could introduce a logic error in your code, these if statements built into the setters protect you from tripping up on one of these truths. This is described as a class invariant. Class invariant is This is something that must be true about our objects, right? The dog age must be greater than or equal to 0, but less than or equal to 30. That would be an invariant of the dog class. So encapsulation is one aspect of object-oriented programming. Object-oriented programming. Object-oriented programming. And the three concepts that people often attribute to object-oriented programming are abstraction, polymorphism, and encapsulation. We've just talked about encapsulation. Polymorphism has something to do with inheritance, which I think actually might be the next video, but I won't talk about it today other than to say polymorphism means you can treat two different objects with the same command, and each of them will get programmed to give a different response. And that's an aspect called polymorphism. And it has something to do with one object inheriting behaviors from a parent object. The last thing I want to talk about today is abstraction, which is another key concept of object-oriented programming. The way I would define abstraction is a distance between using a tool and understanding a tool. The analogy I give in class all the time is when you get behind the wheel of a car, there's only about 6 or 7 things that we can manipulate in that car. You've got a steering wheel, you've got your gear change, emergency brake, windshield wipers, turn blinker, your radio, your fan. There's a limited number of things that you can access from the driver's seat of the car. But if we lift up the hood of the car, there are thousands of pieces of machinery working in concert that allow you to safely get from one location to another. Now, while you're turning the wheel or putting your foot on the gas pedal, you don't actually care how the pistons are moving in the engine block, or how exhaust is moving through the manifold, or that the alternator is generating current. You don't care about any of those details. What you care about is that when you turn the wheel left, the car goes left. When you hit the brake, the car slows down. That's what you care about. That's abstraction. The idea that you could take the complexity of a tool, distance yourself from it, and just understand how to use it. And while there are merits in life to understanding the details of the things we take for granted, in programming, it's a big source of power that we can access tools and use them without needing to appreciate statement by statement how they were written. A great example of abstraction is substring. If I have a string called hello, and it contains hello there, and I want to substring that string, oh my gosh, I can't have code outside the declaration of the class like a crazy person. Let's put this down at the bottom of the main method. And I say hello.substring 5. Well, look, someone wrote the substring method, and that awesome programmer, whoever they were, I'm sure they built it really well because it's worked correctly every time I've ever used it. Do I need to know what the lines of code are that allow you to substring a string? I really don't. I need to know how to use it. I need to know what the parameters are. I need to know what to expect. I need to know what possible errors there are. But there's probably dozens, if not hundreds, of lines of code that make up the substring method in the string class, and I just don't care about it. Substring's functionality has been abstracted from me. The same thing can be said about the objects that I define in these helper classes, right? So when I say dog D2 equals new dog, boomer negative 29 true. Well, just this one line of code right here, it's going to take advantage of variables I declared, a constructor I wrote, a setter that protects the age. There is a lot going on behind the scenes of this one line of code. And sure, because I just wrote it, I kind of remember what it does. But as your skills as a programmer develop and you start to write hundreds and hundreds of lines of code, you're going to forget after a time what it was that was the intent of your code that was done a while ago. And it's important that you tested it thoroughly, that you trust that it works correctly. And then you can just let that code live in a helper class, and you can just refer to the constructor and the methods that are there. You understand how to use a dog object, but you won't necessarily need to know how exactly does the if statement work inside set age. Maybe it's good to know what the invariant is. What are the parameters? Age must be greater than 0, less than 30. Sure, that's useful. But the idea behind abstraction is, look, there's going to be a lot of details built into the dog class. Don't worry about the details. Just focus on what the functionality of the class is. So those are two of the important concepts of object-oriented programming. Encapsulation is protecting our fields with the private keyword, giving them only access through public setters and getters. And abstraction is a distance from the details of our code, whether it was written by somebody else like Substring, or whether it was something that we wrote. We allow certain complexity to get abstracted so we can casually and easily use those tools later and worry about other new tools that we're building. So that was encapsulation and abstraction. Thanks for watching.